Hello friends, how are you all? Welcome to Chemistry Art. Myself Pai Kumar Patel, and today we are going to discuss how to measure electrode potential of any electrode with the help of the standard hydrogen electrode. So first of all, what do you mean by standard? Standard means the temperature should be 298 Kelvin temperature. The pressure should be 1 atmospheric pressure or 1 bar pressure, and the concentration of the electrolyte should be 1 molar concentration. And here we are taking the hydrogen cell. So if the hydrogen electrode is at this condition, so temperature 298 Kelvin, pressure 1 bar or 180 m, and the concentration of the solution is 1 molar, then we can say that it is working as standard condition. So at this time, whatever potential it is giving with the another cell is known as a standard electrode potential, and we are taking the hydrogen half cell or hydrogen electrode as a 0.00 watt. So we are taking hydrogen electrode potential, standard hydrogen potential, as a reference. So it is known as a SHE, S for standard, H for hydrogen, and E for electrode. So standard hydrogen electrode we are going to see, and you can see the figure is given here, and here you can see easily that how and what is the structure of this hydrogen electrode. Okay, so let's see that how hydrogen electrode is working when it is attached with another electrode. So we can get the potential of another electrode with the help of this hydrogen electrode, standard hydrogen, and it is known as a E0 of any another cell. Okay, so we are taking the hydrogen as a reference cell, and now we have to see how can it work. As we are knowing that the cathode and anode, on the cathode the reduction is taking place, and on anode the oxidation is taking place. So sometimes hydrogen is working as a cathode and sometimes it is working as an anode. So now see, we have taken 1 molar HCl solution in which H plus ion is present, and then after we have to see what we are having different. We are having the hydrogen gas input, okay, which is having 1 bar pressure. So from here hydrogen can be added, and we are having another side from where the hydrogen gas can be come out. Okay, because in this electrode, the hydrogen electrode can generate the hydrogen gas, and it can also used. Okay, so hydrogen gas can be used or hydrogen gas can be evolved. It is depend on hydrogen electrode is working as anode or cathode. Now see what we are having another thing in the electrode. See here the wire is there, and the wire is attached with the platinum foil coated with the platinum black. Okay, so it is just for transfer of the electron from the solution, okay, from the solution to the wire or wire to the solution. Okay, and gaining of electron or losing of electron can be done by the hydrogen gas or hydrogen ion from the solution. Okay, so now see how we can use hydrogen electrode to measure the electrode potential. So first of all, we have to see that how hydrogen electrode can work if it is working as an anode and if it is working as a cathode. Which reaction can take place on this electrode, because here both the reaction can be take place. So let me write here. First of all, we are going to see if the hydrogen electrode, is working as a anode. Okay, if it is working as an anode, so what reaction can take place here? As you know that anode means what? On anode the oxidation can be take place. So oxidation here, if the hydrogen is working as anode, so oxidation will be take place at the electrode. And oxidation means what? Oxidation means you should know that it is the process in which loss of oxygen is occurring. So if hydrogen is working as anode, it means that hydrogen will lose electron. And how hydrogen can lose electron? See here, there is no any solid hydrogen is present. Here we are passing hydrogen gas. Okay, so its molecule is look like that. The hydrogen, two atoms are there, and if electron is loosed, then it is loosed by the hydrogen gas, because in the solution the H plus is there and H plus is not having its electron. So here H2 will be used, H2 gas will be used, and it will lose 2 electrons. Okay, so can I write like this? H2, it is losing electron, so arrow, and then after I will write, after losing it will convert into the H plus only, so H plus 2 H plus I have to write, because single hydrogen is not there, H2 is there, and 2 electron will lose. Okay, so these 2 electron will be moved from the platinum plate to the wire, and wire to the another electrode, whatever electrode is attached. Okay, so here see the hydrogen is coming like this. Okay, in the solution hydrogen is what it is doing, it is losing electron if it is working as an anode, and when it is working as an anode, if the another electrode is having higher capacity to gain electron, at that time hydrogen have to lose. Now see another chance, if the hydrogen is working as a cathode, what will happen in this condition? So if hydrogen is working as a cathode, you know that what happens on cathode. Cathode means carry, carry means what? K for cathode and Re for reduction, and reduction means what? See, I told you carry means to hold. Okay, to gain, I can say gaining of electron means it is reduction process. It means that if hydrogen is working as a cathode, it means hydrogen electron will gain the electron, hydrogen electrode will gain the electron, and the another electrode which is attached with the hydrogen, it will lose electron. So see, electron will comes like this, okay, from the wire to the platinum, and in platinum plate it is in a contact with the H plus ion. So H plus ion, it is positive ion, so if we are giving the electron to the positive ion, it will obviously gain the electron, and I can write the reaction equation like this. See, H plus plus E, because one H plus will gain one electron and convert into the H, but H2 is forming. See, a bubbles are there, so hydrogen gas will be formed. So I have to write here 2H plus, and 2H plus will gain 2 electron, and you can see here, see, if the hydrogen electrode is working as a cathode, then the hydrogen gas will be formed, and that's why we are having the outlet here. Okay, so if the hydrogen is working as a cathode, so from this outlet the hydrogen gas can be come out. Okay, so like this, hydrogen can work as a cathode and hydrogen can work as a anode, depends upon the another electrode, which electrode we are taking. Okay, so it is depend on the another electrode. If we are talking about in respect with the electron gaining capacity, then if the another electron is more electronegative, it means that it is having more capacity to gain electron than hydrogen, then hydrogen have to lose electron, and if hydrogen is losing electron, it is working as anode, and if the another electron is not having tendency to gain electron, it is having tendency to lose electron, then hydrogen will gain electron and hydrogen will work as a cathode. Okay, so here two conditions are there, hydrogen working as an anode, this reaction you have to remember, it is must. Okay, and then after the if hydrogen is working as an anode, so here H plus will be formed, H2 will be used, and if hydrogen is working as a cathode, so H2 gas will be formed. Okay, so now it is all about the hydrogen electron. Now let's talk about how we can measure the electrode potential of another electrode with the help of hydrogen. So we are having this hydrogen cell. As I told you, the potential of hydrogen we are taking as a 0 watt. Okay, now we will attach this hydrogen electrode with the another electrode. So this hydrogen electrode is our half cell. Here we are having galvanometer and it is attached with the another half cell. This is the metal rod, okay, of particular metal, and in the container we are taking the solution and attaching these two solution with the help of the salt bridge, in which we are taking the KCl. Okay, so suppose we are taking this zinc plate and we have to take the zinc sulfate solution. Okay, and now we are going to measure what is the potential of zinc. So here standard potential, because we are always taking standard potential of fixed value, it will give. Okay, so standard potential of zinc means I can denote it like this: Zn naught Zn slash Zn 2 plus. So what is the potential? Here we are having the hydrogen, it is 0.0 watt, and again I am telling you, whatever potential it will give, it will be the standard electrode potential of zinc. Just we have to see that here hydrogen is working as a cathode or anode. So if you remember that the zinc is more, in the terms of electron loss, zinc is more reactive. So zinc will lose electron and hydrogen will gain electron. You can see that this is a reactivity series of metal where zinc is more reactive than the hydrogen. It means that zinc will lose electron. We are talking in the terms of the losing of electron. Okay, so zinc will lose electron and hydrogen have to gain electron. It will gain electron. Okay, because zinc is above the hydrogen in the reactivity series of metal. So when zinc is losing electron, you can see the electrode will be like this, because zinc is continuously moving into the solution as a Zn2 plus, and the electron which are releasing, it will move towards the hydrogen cell. So zinc is losing electron, it means that it is working as an anode, and here the electrons are moving towards the hydrogen electrode, and here hydrogen ion will gain electron and convert into the hydrogen gas. So I can write it like this: 2H plus 2 electron, it gives H2. Where at another side the zinc is working as anode, so here hydrogen is gaining electron, hydrogen electrode is gaining electron, so it is working as what? If it is gaining, it means that reduction, and reduction means it is working as a cathode. Okay, so this is the reaction at which the zinc is losing electron and hydrogen is gaining electron. So zinc is our anode, zinc is our anode. It is losing 2 electrons and converting into Zn2 plus. Okay, so now like this you can measure any of the electrodes electrode potential, and when we are measuring this, the electron are moving from zinc to the hydrogen, it means that the flow of electron is there. It means that at 298 Kelvin temperature, water flow of electron is generating with 1 molar concentration and 1 bar atmospheric pressure or 1 bar gaseous pressure of hydrogen. So the potential whatever we are measuring on the galvanometer is the electrode potential of zinc, and not only electrode potential, it's a standard electrode potential of zinc. And if we are taking the value from the galvanometer, it is generally giving the 0.76. Now see, it is in terms of gaining of electron or losing of electron. So if we are writing the electrode potential of zinc in terms of losing of electron, it means that we are writing the oxidation potential of zinc, and it is 0.76. it's a positive value. But the electrode potential of zinc, if we are taking reduction potential, then the value will be same but the sign will be changed, 0.76, it will be minus. So reduction potential of zinc is minus 0.76 watt and oxidation potential is plus 0.76. it means that reduction potential and oxidation potential values are same for any electrode. So this is how we can measure the electrode potential with the help of hydrogen cell. Thank you very much.